Hi, I'm Vivian.
I'm Austin.
Hi, I'm David.
Today we're going to be explaining protein synthesis by baking a cake.
In order to get our body's functions, we need proteins. When you get these proteins, we need the instructions in DNA. It's like baking a cake. You need the recipe book to get the cake.
The first step of protein synthesis is transcription. This is the process of taking information in a strand of DNA and copying it in the form of messenger RNA.
The segment of DNA that is being copied is the transcription unit. In our cookbook, this would be the recipe. There are 3 steps to transcription: initiation, elongation, and termination. The first step, initiation, is where transcription begins. It's like opening up the cookbook. To start transcription, a promoter is needed to tell the enzyme RNA polymerase where to start transcribing, like how the title of the page tells you what recipe you're looking at. The RNA polymerase separates the DNA and reads the strand. This is the beginning of elongation. The polymerase moves along the unwound strand and makes a complementary strand of RNA. It's like us copying down the recipe onto a piece of paper. Termination is the last step of transcription, in which a terminator tells the polymerase when to stop copying. From there, RNA processing starts. A spliceosome cuts extra information. The information that gets cut out are the introns, and the information that remains are the exons. The final product of transcription is the messenger RNA.
To keep the mRNA together, a 5' cap and a poly A tail are added to the beginning and the end of the mRNA.
The mRNA then moves out of the nucleus, or in this case kitchen drawer, into the kitchen, which is cytoplasm, into a ribosome, which would be the kitchen counter.
Protein synthesis is translation. Like transcription, it has 3 steps: initiation, elongation, and termination.
The initiation stage brings together mRNA and tRNA.
Our initiation stage is putting our ingredients on the table. Amino acid activation is what creates a tRNA carrying an amino acid.
An enzyme binds to an amino acid and ATP. The ATP loses 2 of its phosphate groups and becomes AMP. The tRNA then enters the activation site and covalently bonds to the amino acid. AMP goes away and tRNA with this amino acid leaves the enzyme.
Amino acid activation is similar to a factory where ingredients are put in its container and put together. For example, the egg is put in the container, or carton.
During the next phase, elongation, the amino acids are put together. This happens over 3 different sites: the A site, P site, and the E site.
tRNA enters through the A site. If a codon on the mRNA matches the anticodon on the tRNA, it moves to the P site. The codon and the anticodon are like how the recipe and ingredients match.
The tRNA drops off its amino acids at the P site and moves on to the E site where it exits the ribosome. This process continues with each new tRNA adding on their amino acids to the polypeptide chain. Once the entire sequence of mRNA has been read, a stop codon signals the ribosome to stop translating. This is the termination stage. This is the polypeptide chain, or the cake batter. The polypeptide chain is folded to make the end product a protein, or in our case, a cake.
Beep, beep, beep.
This is our final protein.